Hi, welcome back to the channel. My name is Aquib, and in this video, we are going to explore the MongoDB NoSQL database and also take a look at how to connect it with an ExpressJS backend. We'll start by creating a brand new MongoDB cluster and then write the code to connect it to an ExpressJS server. Let's head over to the MongoDB website and get started. So here we are at the official MongoDB website, which is mongodb.com. As you can see, this is actually a pretty good looking website. And if you spend 5 minutes scrolling down and reading the whole thing, you will actually understand what MongoDB is all about and how it works as well. But for now, what we are going to do is to jump to the account creation. So if you don't have an account already, you can click on the try free button and you can then go ahead and create your account. Since I already have an account, I'll head over to the sign in. Remember, if you're creating an account for the very first time, it is going to ask you for a simple questionnaire which you can fill in. It'll just ask you some basic details about who you are and why do you want to use MongoDB, or what are you planning to do with MongoDB. So you can quickly fill that questionnaire in and that will take you to the next step. Typically, after we create an account, the first thing that we are required to do is to create a new organization within our account. As you can see, I already have a couple of organizations from my previous projects. But what I'm going to do is to go ahead and create a new one. You will find a similar interface when you set this up as well. So the only thing that we have to specify here is the name of the organization, which I have written over here, as you can see. You can let the default selection be that's MongoDB Atlas and then go ahead and click on the next button. This will then create the organization for us. Again, you can just keep all the default settings and create organization. As soon as that is done, the next step is to create a project within that organization. So again, if you're doing this for the very first time, then it will automatically guide you through all of these steps. But let us say that you already have an account, then this is how you do it. You click on the new project button and then we can just go ahead and enter the project name. So I'm just going to type in a name, which is task manager. That's what we are creating in this case. So I've just entered the name over there. Again, we don't need any key value pair, so I leave that be. Click on the next button. Then it will take you as the default owner of the project, which is perfect, and click on the create project button. This takes care of the project creation for us. And finally, after we have a project, we can go ahead and create a cluster, which is where our database will eventually be. So again, 3 steps. Number 1, you have to answer the simple questionnaire while you sign up. Number 2, create an organization. And number 3, create a project within that organization. Once all of this is done, we reach this screen, which is our cluster. So we call this a cluster and we can click on this create button to create a new one. Now you will see a couple of different options in the left menu as well. But again, I'll walk you through the steps one by one. The very first thing is to click on the create button. This will again pull up a guided step-by-step menu for us. So the first thing again is the name of the cluster here. You can either leave it with the default name or change it. So I'm going to use the same name as the project name. The next step is to choose the free option, which you can see is the third option over here. The first one is M10. This is a paid cluster or a paid server. As you can see, the rate is also indicated over there. The second one, serverless, is also a paid setup, as you can see. And the third one is free. So this is shared. It's actually very weak in terms of the server capabilities, but more than enough to create a portfolio project. So I'm going to choose the free one here. Make sure you choose the free one, otherwise you will be billed and we don't want that. So we have chosen the third option here, which is free. Then I've already given the name of the cluster. You can give it whatever name you want, doesn't really matter. But you can read this here. It says once you give the name, you cannot change it. So again, be very careful with the name that you give. We will use this name every time we connect to the database. Then I'm going to uncheck these two options. We don't really want any security setup and we don't really want any sample data as of now. The next section is where we have to choose a provider. And again, it doesn't really matter which provider you pick. All of them give us free options. Just make sure you pick the cluster or the provider which is closest to your audience. So since I am in India, I'm going to choose an Indian provider. If you are in any other part of the world or your audience is in any other part of the world, you can choose a relevant setup for that particular region. You can see we have servers available all across the world. So make sure you choose the location which is nearest or closest to your target audience. So again, I'll stick to AWS and India. It doesn't really matter which provider you choose, whatever code we write will not be affected. This is an internal MongoDB setup, so you can choose whichever option you prefer. It will matter in the paid setup, but since we are working with the free plan, it doesn't really matter much. Once we have selected this, we can then go ahead and click on the create deployment button. This is available on the bottom right. So I'm going to click on that button and it will then take us to the next guided step. The next step in this setup is to create two things or set two things. One is the IP address setup and then creating the database user. Again, it automatically pulls this up for us. If you close this off by mistake, I'll show you where you can access this in just a minute. So the very first thing that we have to choose is this third option, allow access from anywhere. Now we can restrict it to a particular IP address as well, but right now I'm allowing access to everyone. So this is the IP address 0.0.0.0/0. This means anybody from any part of the world can access the data. So add IP address, that is done. All right, so our IP address, as you can see, is set. The next step is to create a database user, and it is really important for us to remember these credentials because we will be using them every single time when we establish a connection with the database, right? So we have to write this within our server-side logic. So make sure you remember these credentials. It's a difficult task to reset them later. So I would suggest you can probably note it down somewhere which is secretive to you or some place that only you have access to. I'm going to create a new user here. So let's call it test user 100. So this is my username. You can of course make it a little more complicated, but since this is just a demo, I'm keeping it simple. So test user 100 is my username, test user @100 is my password. You can copy this from here if you want to and save it in a place that you will remember later on. I'm going to create database user and that's it. Now we can choose the connection method and close this off. We'll worry about where to get the connection string from in just a minute. But for now, you will see that our database deployment section is now showing up. And over here, we have our cluster ready, which is Task Manager. On the left hand side, we can now head over to the database section or the database menu. And here we'll see a detailed overview of the entire database. You have two more options in the left menu, that's database access and network access. So let us say that you skip creating that IP address setting. You can do that from here. So you can just add a new address from the option on the top right. Similarly, you have database access. So in case you forget your credentials, you can come here, probably edit this user or delete it and create a new user with new credentials. Again, just click on this button which says add new database user and you can set it up. But hopefully you have already done this like I told you to. So after the entire setup, what we have is this database deployment. And again, if we just go ahead and check this out now, it will be empty because we have not loaded the sample data set and neither have we written any code to put some data in. But this is the entire MongoDB setup that we need to do before we can actually connect this to an ExpressJS backend or any other backend for that matter. Perfect. Now that we have our MongoDB setup in place, let us head over to VS Code and start working on the Express logic. What I've already done for us is I've already written the bare minimum Express code which we need for this application. So if this is your first time working with Express or you don't understand the code written here, I recommend you check out my video on an ExpressJS mini project. I'll link it at the top here and I'll also put the link in the description box. Once you have gone through that video, you can come back and continue from here. I've also added this starter code in a GitHub repository. You can find the link to that in the description box as well. You can get the starter code from there and follow along. Okay, so let us start by creating or initializing a new node project. So I have not done that as of now. I have just pasted the code in this file. So let's head over to the terminal, new terminal. And then the command for this is npm init, right? And we have the y shortcut. Again, if you don't really know what this command means or why I'm using it, make sure you check out the video on ExpressJS. So I'll hit enter here. This will initialize our package.json file for us. And let's quickly change the test script to a start script instead. And this will be node index.js. So this is the starting command. And I'll also add the author name over here. Done. This is everything we need to change for now. Next up, let us go ahead and install all the packages that we're going to need. So we need a bunch of different things here. First up, we need Express, then we need body parser. In addition to this, we need two packages to work with MongoDB. The first one is Mongoose and then something called .env. This will help us hide or secure our database credentials. So these are the two additional packages that we're installing. And again, if we need anything else later on, we can always install it that time. Now, if you're wondering what this Mongoose package is, well, it is a very handy package to work with MongoDB. In fact, if we just go and check the documentation out, you will find that this is one of the most common packages used by developers, right? While working with MongoDB, MongoDB does have their own NPM package as well. The official MongoDB package is also available, but most developers prefer Mongoose because it has been around for a very long time and it actually works really well. The documentation is good and the syntax is pretty simple. So you can check out the documentation as well. I'll put this link in the description box as well. Let's go back to the code, however, and continue working on our logic. So we need 4 packages. I've just listed them down and I'll hit enter. This will take care of all the package installation for us. Now this might take a minute because we have 4 packages being installed at the same time. All right, this is done. Let me close the terminal off and now we can focus on the logic. So first up, let us go ahead and require the Mongoose package. So we can require it like any other normal package, right? So let's require that. Done. Now for the .env package, the requirement is a little different. What we have to do for that is we have to create a file which is literally .env. The extension is env and there is no name. These kind of files are hidden files in the system. They are called dot files. They are hidden by default. So the idea with the .env package is that we enter our credentials over here. So the MongoDB URL which we get from the database will go here and it will remain a secret because this file will never be deployed. It will never be uploaded to GitHub either. Now, how do we get this URL? Well, for that, we can go back to our database and then we can go to the overview section. Once we get to the overview section, we have to click on the button which says connect. So again, we are in the database menu and you will find the connect button over here on the right hand side. So I can click on that connect button. This will pull up several different connection options for us. We are looking at drivers. So let's click on that. And then this is the URL that we have to copy. So you can click on the copy button and get it from there. That's it. That's the only thing that we need from the database. I can paste that URL over here. Now there are 2 changes that we have to make in this URL. First of all, you will notice that the password is missing. So we have to replace this with our actual password. Now, since I am demonstrating this to you, I am actually showing you my password, but make sure you don't share this password with anybody else. So this is the first change. The second change that we need to do over here is to add the name of the database, which needs to be added before the parameters, which is before this question mark. So after this slash, we can add the database. Let's call it tasks. This will be the name of the database. We can also call it task manager. If you don't give a custom name, then test is the default name that is taken. TEST, that will be the default name that MongoDB will take. So I highly recommend that you actually add a custom name over here and then the database will be created with this name. So again, we have done 2 changes here. The first one is to replace the password with the actual password and then adding the database name just before the query parameters. So just before the question mark. Then there is a special way to actually initialize this. And for this, let me actually show you the documentation. So let's go for .env documentation. I'll just search for that and it will be the first thing that shows up. When you scroll down, you will find a bunch of different examples. And this is the one that we want. Require .env config. So require .env config. I can copy that one line and then go ahead and put it up at the top. This should typically be the first line in a server because what this will do is it will basically take all the values that are available, all the key value pairs that are available in the .env file and make it available on the system process. So we can access it from there. Now, how do we access it? Well, let me show you. We can say const db underscore URL and this can be process.env.mongodb URL. So this needs to match the name that we have given, which is this one, MongoDB underscore URL. So this way, what is actually happening is we have separated our database credentials from the actual implementation logic. The credentials stay in a secret file, which is not visible to anybody who has access to this index.js file. Similarly, when we deploy, we can actually get the port from env as well. So we can say process.env.port. Again, when we deploy a project like this, the deployment server will automatically assign a port that is available. It might not happen that the port 3000 is always available. So this is how we can set this up. So we either take the value 3000 or take the value that is coming from the system. So this is the setup that we need to do before we can actually start working with the data. The next step then is to actually create two other things, something known as a schema and then something known as a model. Now, traditionally, we go ahead and we create separate folders for it. So we make a folder called schemas where we keep all the schemas. Then we make a folder called models where we keep all the models. But this is done typically in cases where we have multiple items to work with. Since in this case, we are working with a single database entity, we can actually create everything within a single file as well. So let us go ahead and create the task schema first of all. So the schema is basically the definition of a task. We have to specify what are the different values a task can contain and what are their data types. So for this, what we can do is we can create a schema. So that's const task schema. We can create it using mongoose.schema. So there is a class available within the mongoose package called schema. And then within this, we have to specify all the properties along with their data type. So for example, this is the title of the task. We can also have a description of the task. So that can be description. This can be another string. Then we can have, let's say, due date. This can be of the type date. And then we can have a fourth thing called completed, which can be a Boolean value. So this can be a true or a false value. If we want more control on this, we can actually expand this as well and then specify the type. All right. We can also specify whether it is required or not. So required or require, this can be set to true. This would mean that it is mandatory for the title to be available when a new task is getting created. So we have a couple of different such properties which we can set. For now, I'll keep it simple to string. Basically, when we perform any kind of database operation, what Mongoose will do is it will come back to this schema and it will check our data against these parameters. If our data contains anything outside of what we have specified, it will give us an error. So if something is missing, that can be an error. If something is additional, that can also lead to a problem. Again, something is missing in this case will work fine because we have not specified required true. But if you specify that required true for all values, then it would mean that all of those values will be needed. And if any of those are missing, then the insertion will be a problem and it will throw an error. Perfect. So this is the first step. We have to create a schema. Based on this schema, we can then create something called a model. This model is the object which will be the actual interaction object throughout our code. So how can we set this up? Well, again, we can say const task model is equal to new mongoose.model. Now this is lowercase m, so be very careful with this. It is not uppercase, but in fact lowercase m for model. For schema, it is an uppercase s. So I know there are a little bit of discrepancies, but that is how it is. Then we have to specify the name of the model. So that's task. And the plural of this will be the collection name in MongoDB. So what Mongoose will do is it will take this model name, it will create or pluralize it. So it will create the plural version, which is tasks, and that will become the name of the collection. And then we can specify the schema on which this model is getting created or based on which we are creating the model. Right? So this is how the model has been created. We can also call it the same value as the name here as well. Doesn't really matter. Right? It will be fine if we give different values. But to maintain consistency, we can also use the same values. So this task and the name that we have given can be similar. Perfect. Now that this is done, we can actually connect to the database and then start working on the actual CRUD logic. The connection will happen in the app.listen. So as soon as the server is initiated, then we can go ahead and connect it. For connection, we just have to say mongoose.connect and then pass in the URL. That's the db underscore URL, which is coming from our process.env file, right? Process.env.url. Now, If the connection is established successfully, there will be no errors thrown. But if you see any error at this point, it would mean the connection is not working. The most common error that we get typically is bad auth, because in a lot of cases we forget to modify these details. So make sure you have modified your password. And now let's test the connection out. The command for this is npm start. Let's put that in and try to connect. Now we will get an error here, and this is intentional, because what a lot of us will do is we'll use a special character in the password, which is what I have also done. If you remember, my password is actually @100, right? And you can see here it says URI must contain hostname, domain name, and TLD. Basically, URI is a special version or a special format of the URL which is encoded. What that means is the browser will use some special characters called encoding to indicate these special characters. So instead of @, we have to actually put %40. You can find a lot of free URL encoders on the internet. I link a few in the description box as well. You can just go over there, put whatever special character you have, and it will give you this particular code which you can use instead of that special character. So I'm using %40. And now if I go back and run the same command again, you can see this time there is no error and the connection is established successfully. Now that a database connection is set up, let us go ahead and start working on the API endpoints logic that we have. So we have 5 different routes that we have to set up. Let's quickly get this going. The very first route is for creating a new task. So over here, what we need to do is we need to read all the task details from the user, create a new task based on our task model, and then insert it into the database. So let's go ahead and get this done. The very first thing that we have to do is to read all the details from the request. So we can use the destructuring syntax for this. So we have task, description, then the due date, and then the completed. These are a few values that we need from the request.body. Right? So this is how we can destructure that. Then we can create a new task based on our task model. So that will be await and then task.model. I've already put in the async over here if you notice. So that's why we are able to use await here. If you don't put this async, then this will lead to an error again. Perfect. So instead of model, we actually have to write task.create and then provide those values here. Now MongoDB will automatically generate the ID for us. So we don't have to worry about the ID. We just have to pass in the other values. So these are the 4 values that we pass in. And then this create method is actually going to create a new task in the database. There is another option called save, which we can also use if you want. Then we can respond with a success message. So we can put the message as 201, that is for created, and we can respond with the new task. So this is our logic for posting or creating a new task. Now let us go ahead and test it out. So for this, let us start a server first. So let's npm start. That should trigger the server for us. Perfect. Now let's head to Thunder client, and on this URL we have 3000. So let's put that in. So that's going to be HTTP, then localhost 3000, and then our endpoint here is actually /tasks. Let's take that in and put it over here. Make sure you put all the brackets very carefully or all the slash here very carefully. Then we have to provide the data within the body in a JSON format. So let's go ahead and do that. What values do we need? Well, we need these 4 values. So let me paste those in. And we have to make sure that this is valid JSON. So that means everything must be covered in double quotes. Key as well as the value, everything must be covered in double quotes. Then we should have colon with the actual data. So let's just say the task is cook food, for instance. This is my task. Then the description, I'll just leave it blank for now. Now for the due date, we need to put a valid date, right? So we can just put a date like this. That's year. Let's go for a random month and a random day. And then we can also set the completion to true or false. Let's keep the default value as false. Okay, this needs to be in double quotes and we can give it false. Perfect. So this is our JSON string. The cross will go away. So you will see this cross here if it is incorrect. As soon as we fix everything, the cross goes away, which means our format is now correct. Make sure you change it to the post method and then send it. As soon as we send it, we get a 201 created, and you can see we get a ID as well. So this is something that is coming from MongoDB. We can go ahead and now check our database. So if we head back to MongoDB, click on the refresh button. or rather let's first browse collections. So we have collections right here. Let's click on that and this should take us to the collections section. Now you will see on the left hand side, task manager is the database name within which we have a tasks collection, and then the data that we have just added, which is cook food, has now been inserted into MongoDB or into our database. Perfect. So this is the insertion of a single post. In a similar way, let us go ahead and set up the rest of the endpoints as well. So the next endpoint that we have is to get all tasks from MongoDB. So this should return everything that is available in the database. For this, we can just store them in a variable. So let's call it tasks. And again, we can just say await task dot find. So this task is the model that we have created, and find is the mongoose function which will fetch everything from the database. If you have a particular constraint, you can put them in these curly brackets. But if you just want to fetch everything, then you can let them be. So this task.find should fetch all the tasks from the database, and we can just say response.json and send that back. Let's move to the next one. So this is where we can use that specific find logic. So since we are working with an ID here, we can actually use another method which is called find by ID. So let's set this up. For this, we are going to need an individual task. So let's set that up. So that's const task is equal to, and then again, it will be task dot find by ID. This is the function that is available. And over here, we have to provide the ID, which is coming from request.params.id. Now, if this task is found, then we can return that. Otherwise, we can throw an error. So here we can say 404 not found. So that will response.status 404 and then .json. We can put a message saying not found. So we can put a message here. This will be whatever we want it to be. So we can say not found because it's 404. It is anyways indicated. Right? This is going to be a not found message, and this needs to be in curly brackets to make it a valid JSON object. Otherwise, if that is not the case, then we can respond with the task that we have found. Perfect. So this is the logic to get a specific task. Let's quickly work on updation and deletion. So again, most of the logic will be the same because we still have to find the task first. And only if we are able to find the task using that ID, will we actually be able to update it. So for update, we are using the patch method, and then for delete, we are using the delete method. So let's call it update task instead of an individual task here. And then we can check the same thing for an update task as well. If it is found, then we can go ahead and modify it. Otherwise, we can throw an error. Also, we need to read the details just like we have read them above because the values need to be modified. So let's fetch everything again. So we have fetched the values from the request body. We have fetched the updated task. Assuming that the task is available, we can now work on the update logic. So for update, we have another method available called find by ID and update. So this will actually save us the trouble of checking this condition. If you go with find by ID, then you will first find it, and only if it is found, you can write the update logic. But otherwise, we can directly just write that logic over here as well. So find by ID and update, and then in that updation, we can pass in all the parameters which are available over here. So we can put a comma after the ID, and then we can paste the entire object. So this will take all of these parameters and make those changes into the database. Done. We can also then set another property here called new. So this means that if the task is not available by default, then we can create it. So in case a task with this ID is not available, then instead of updating it, go ahead and create a new one. This can be updated task, and we can just respond with this at the end. So this is our updation logic. Again, what we're doing here is first we are reading all the data from the body of the request. Then we are finding by ID and updating it. So we need to pass the ID, the values that are to be updated, and if it is not available, do you want to create a new task or not? Now for the deletion part, we can use an existing method which is find by ID and delete. So this is another mongoose method and also a MongoDB function which is available, and this allows us to delete a task. So we can again say request.params.id. So it will take the task with this ID and simply delete it from the database. Once the deletion is performed, we can then respond. So we can say response.json and we can send a message saying task deleted. Perfect. So this is everything that we need, and that's it. This is our entire logic. Let's go ahead and test it out. So we have to restart our server first. That is done. Now let us create a new request here, and let me just copy this. Let's try to insert something new. Remember, this is not local data anymore. This data is actually stored in the database. So whatever we have stored earlier also will still be there, right? So let's just say I change this to buy groceries instead. Let me change the date as well. So I will send this and a new task has been created. Perfect. Now let's go to our get route and try to fetch all tasks. I'll also copy the ID of one of these tasks so that we can test that route as well. Now, when we go to all tasks, you can see 2 tasks are being returned. This is exactly what we wanted. Now let's pass the ID in, send it. Okay, so this gives us some error. It says connection was forcibly closed. Let's actually check the error out and then we can take a look at how to fix it. So this error has got something to do with some stringify values. It says circular structure to JSON. The problem basically is that we are trying to access the ID, right? And we are trying to return it back to the user. So what we can do is instead of returning the entire ID, we can actually extract the data that we want and then only return that much. So we can create a new object calling it task data, and then we can extract whatever we want from it. So the ID is accessed by underscore ID, and then let us say that you only want to return the task title. So that will be task.title. And then instead of returning the task, we can return the task data. Let's restart our server and check this out. So I'll hit the request again. And this time you can see it says status 200 OK. We don't see any values, probably because something is wrong over here itself. Let's double check. We are saying const task equal to, and yes, await is missing. That's the problem. So that's it. Now let's double check. So stop the server, start it again. Go back, let's hit the endpoint, and you can see now we are able to get that data. So again, if we face any issues or errors, there is always a fix that is available. So don't worry if you face things like that. You can now go ahead and check the other endpoints out as well in a similar way. Updation and deletion should also work fine. We can just put a patch, right? We can probably pass in, let's say, sell instead of buy, send it. And again, you can see a similar error. So you can try to fix this on your own as well. So if we take a quick look at the code again, we have first required everything that we need, and I've also created the .env file on the system. This is where we have the database URL. We have modified the password as well as the database name over here. Then we are establishing connection to the database. That is being done in the listen method down here. So mongoose.connect. And then we have gone ahead and written all the other insertion logic. Before we work with the endpoints, however, we have to create the schema which specifies how our data is going to be, and also the model which then builds upon the schema and gives us an instance which we can use to perform CRUD operations to the database. Again, you can find the final code available in the GitHub repository. The link will be in the description box. So there we go. This is how we can create a MongoDB cluster or database and connect it with an ExpressJS server. If you found this video useful, do like the video and subscribe to the channel for more. Let me know which technology or project you want me to build next in the comments below. Thank you so much for stopping by. I'll see you in the next one.